Hi dear students, okay, hope you are doing good. So welcome to today's Brainiacs Capsule. So we have a new chapter in front of you. So we will discuss hydrocarbons chapter, the most important 3 questions I have taken for you. Okay, I hope all of you are preparing well for the Neet exam. Okay, so if you are finding it any difficulty, feel free to put as a comment on the comment box. We are here to help you. Okay, so the question, let us start with the question. Okay, so the question here is, let's see. Okay, let me take a good color for you this time. Yeah, red we will take. So the question here is, which of the following compounds, okay, with molecular formula C5H10 yield acetone on ozonolysis? So what is peculiar about this question, sir? What do you feel? Very simple. They have given you the product actually. Okay, so the product is given. What is the product? What is the product they have mentioned? We know that a reaction has happened and there is a product they have mentioned, and the product what they have mentioned here is acetone. Okay, so that means you have 4 options given there. So if any of these reactant, I don't know which is that reactant, which on ozonolysis gives you what? Gives you acetone. We should get acetone from that. Okay, so that is the challenge. Now how we can do this? Okay, so let us try to do that. The most simple way is take one by one option and do the ozonolysis and check whether you are getting acetone. This is the direct method. Okay, now I will tell you one more simple method actually. Okay, one more simple method in the sense we need to understand what is the structure of acetone, and based on that we need to take a choice from the option. That will save your time little more. Okay, so tell me, sir, what is acetone's structure? Can anybody tell how acetone looks like? Okay, so let me say acetone is CH3. Okay, CH3 C double bond O CH3. Okay, now you know that during ozonolysis this double bond O is actually coming actually. For example, I will show you one simple ozonolysis example. So you can see, for example, you have a compound like this. Okay, CH3 CH double bond CH. Okay, CH3. Now how will you do ozonolysis for this one? Very simple. Split the double bond completely. Okay, put oxygen on both sides. So you will get the product CH3 C double bond O, oxygen that is added, and H. So here also the same thing, C double bond O, you have H is here and you have CH3. Okay, this is how fundamentally ozonolysis is done. So I know that here C double bond O is coming because of ozonolysis. Okay, so my actual compound should be something like this, CH3 C. You have another CH3 here, then there is a double bond here. Okay, so this is broken and oxygen is coming here. That's why C double bond O is coming. So this is something that should be present in my parent compound. Based on this, I can say I can select which is the compound. Okay, here when I am looking at the structure of different compound, I understood that in the option 4, that is 2-methyl-butadiene. So let us draw butadiene first. Butadiene is CH3 CH double bond CH CH3. This is butadiene. But anyway, I know that there should be CH3 single bond C CH3. There should be something like this should be available. So if you see here, they are telling it is 2-methyl 1 2. So in this one we can see easily here one H should be removed, and instead of that there should be methyl group should be coming. Correct? Then this will become 2-methyl-butadiene. Now if you perform ozonolysis of this, I am sure that you can distribute oxygen on both sides like this. Then what you will get, sir? In the first one you will get CH3, okay, C double bond O CH3. This is what we need, that is acetone, and the next product is CH3 CHO, that is acetaldehyde. Clear? So I can say my answer for this question is option 4. Okay, so why I have not chosen other options? You can see here, this is also 2-methyl, but it is butanene. So butanene means this double bond will be coming here. But in my acetone, you can see there is only 3 carbon atoms. So that is not possible. Here cyclopentane, it's an alkane, so that is also not possible. Here also you can see 3-methyl but-1-ene. Again but-1-ene is coming. The problem with the but-1-ene is like this. I will show you, for example, when you take but-1-ene, what happens fundamentally. Then you will get a clear picture. Okay. Since I have practiced a lot, I know that but-1-ene will not give you acetone. So that is also another reason why I have not chosen but-1-ene. I can show you that CH3, CH2, listen, CH double bond CH2. This is my but-1-ene. Now you can easily say that this is 3-methyl. 3-methyl means 1, 2, 3. In the third position, you should put methyl group. Okay. So let's make it a little more neat. Okay. So here you have, in this position, you have a CH3 group is there. Okay, then you have carbon. Okay, listen, I will make it. Yeah, so here you can see CH double bond CH2. So this is fundamentally my 3-methyl but-1-ene. Now if you are doing ozonolysis for this one, I can say oxygen will come here, oxygen will come here. So this will give you formaldehyde HCHO, and this will also give you an aldehyde only. CH3, CH, and here CH3 is there, and this is also becoming CHO. So very important for acetone, we know that what is the importance? Acetone have 1 carbon connected to 2 methyl group, and that is present only in option 4. That is the reason I have chosen option 4. Okay. So here I have put the things in detail for your understanding. So in the question they have mentioned it is C5H10. Okay, so from this one I can understand it is of the formula CnH2n. So CnH2n means I am sure this would be an alkene fundamentally. Okay, so from this one I know that it's an alkene. Now what is the product you need? This is the product actually you required, acetone. Now I have taken 2-methyl but-2-ene and performing ozonolysis. You can see oxygen coming here. This is becoming acetone. This is my acetone. And the other one is becoming like CH3. Here O is coming CH3CHO. This is nothing but my acetaldehyde. Or we can say IUPAC name ethanol. Clear? I hope it is clear for you. Okay. This is very important question from hydrocarbons. Please learn ozonolysis and go for the exam. Okay. Now let's go to the next question. So the next question is talking about alkyne. Okay, alkyne. So alkyne is here undergoing hydrolysis in the presence of heavy metal cation like Hg2+. Very important reaction, and they are telling you will get a product X which undergoing isomerization gives you another product Y, and they want to know what is X and Y. Okay, so let's try to understand its mechanism, then it will be easy for you. Okay, so first we have something called alkyne is there. So what are the things you should remember, or what is the reaction center of an alkane? I can easily say an alkane has 2 pi bonds. So because of these 2 pi bond, this compound is reactive in nature. Now you are doing hydrolysis, that is water is given. So what water will do in the presence of heavy metal cation, it will undergo splittage. So you will get H plus and OH minus. Now the most important question here is what will happen next? Please understand, because of the pi electrons that is present here, this whole compound has what charge out there, or what field is present? I can say a negative field is there. Negative field. Why negative field? Because pi electrons have negative charge. The pi electrons have negative charge. So that is the reason the opposite charged species among this is the electrophile H plus. So fundamentally the H plus will attack the compound first. Okay, so when H plus is coming to this pi bond will show a polymerization, will show a polarization, and that phenomenon we call that as electromeric effect. Why we call that as an electromeric effect? Because electromeric effect means the pi bond will show the temporary polarization only if attacking reagent approaches, or only in the presence of attacking reagent. So that's the reason why it is called a temporary effect. Only if the attacking reagent comes near to the pi bond, it will show a polarization. Why that is happening? Because it is pi electrons, and we know that electrons have negative charge. and the electrophile have positive charge. So actually here there is a Coulombic force of attraction, and because of that this pi bond is forced to undergo polarization like this. So here the pi bond is polarized like this. Negative pi bond is coming here. So negative charge comes here and a positive charge comes here. And we know that electrophile will attack whom? We can easily say electrophile will attack the negatively charged carbon because opposite charges attract. And you will get CH plus double bond CH2. And in the next step, the nucleophile OH minus will come near to the positive charge and form the compound CH2 double bond CHOH. And this is my X here. In this question, this is my X. And that is present in how many options? We can see that is present in two options, option 2 and 4. Okay. Now let's see what is the importance of this compound. This is an enol. This is an enol. Why it is called an enol, sir? Because the same carbon is carrying a double bond, and to the same carbon atom you have the OH group. So I can say to the same carbon double bond is present in, and to the same carbon alcohol all is present. So we can combine that and say this is enol. Okay, in plus all. To this particular carbon OH is connected and also double bond is present. So we know that enol can undergo a type of isomerism that is called keto-enol tautomerization. What is keto-enol tautomerization? I will explain you, then you will understand the logic. In a keto-enol tautomerization, we know that this is enol form. Okay, we will start with enol, so you will understand the logic what is happening here. Okay, this is my enol. So what enol will do fundamentally? Enol will have a tendency to remove this hydrogen as H plus due to its acidic nature. How I can say enol is acidic? Why you are saying enol is acidic? Because once this compound releases H plus, the remaining structure is stabilized by resonance. You can see that. Yesterday in my Brainiacs capsule, I told that how to test the acidic strength. Remove the H plus and check whether the remaining structure is stabilized. How will you check the stability? Check whether resonance is present or even inductive effect is present. So here you can see this remaining structure is stabilized by resonance. Negative charge, single bond, double bond. Okay, negative charge, single bond, double bond, that is conjugation is there. So what will happen? Immediately I can say this negative charge move to here, negative charge move towards the pi bond. So here you can see it is moving towards the pi bond as a double bond. So automatically the valency of carbon here will become 5. So this pi bond will polarize here as, there is a pi bond here that will polarize here as negative charge. Now you can see the H plus is present in the medium already released. This H plus have a tendency to attack the CH2 minus. So that is how you are getting CH3 CHO. So we cannot say always it will stay like this, because this hydrogen is also acidic, because it can remove the H plus and form this particular structure which is stabilized by resonance. So that is why it will exist between enol and keto form, and this is my keto form. This is my keto form, and they will exist like a keto-enol. Keto sometime, enol sometime, enol sometime, keto sometime. So that phenomenon is called keto-enol tautomerization. I hope you understood the logic. Okay, any doubt? Did you understood the logic how that keto-enol tautomerization is coming? So in the first step, this will release H plus. Why? Because this structure is stabilized by resonance. Then we can say this negative charge will move towards the pi bond. So this will get polarized and come here as negative charge. Then the H plus will attack here. So you are getting the keto form. You are getting the keto form. Okay, so I can say if in sometimes keto form would be more stable, then in the majority of the compound 90% would be keto form, remaining will only be enol form. So depending upon the stability of the keto or enol form, that will dominate in the reaction medium. I can say like that. Okay, now in this one, now I can easily find out the answer. So my answer here would be option, tell me sir, option 2 would be my correct answer. Correct? Here you are getting enol, and this is the keto form of that, CH3CHO. We have just seen that. Okay, I hope you understood. Okay, this can be written as CH3CHO. Correct? This is given in the options. And this is my keto form. Why it is called keto form? Because carbonyl group is present. Any doubt? So again, I am telling, if you have any doubt, feel free to put as a comment in our comment box. Also, you can subscribe, considering subscribe Brainiacs Classes channel. You have lot many classes, almost complete lecture series is present there as a free lectures. You can watch that, take down the notes. Also, we have revision series, everything is coming up. Okay. In addition to that, if you feel like, sir, I need some offline classes, you can contact Brainiacs Classes, which is one of the best NEET institute available in Coimbatore. We have a history of more than 6 to 7 years in this particular field. Okay, so we focus on mainly average students to make, if they have an ambition or a passion to become a doctor, we will try our level best to make him or her a doctor. Okay, we will give them the best training and facilities. Okay, let's go to the next question. Okay, so the question here is, all of you please go through the question. Among the alkenes, which one produces tertiary butyl alcohol on acidic hydration? Acidic hydration or acid hydration means in the presence of an acid, that means the medium is full of H+, you are adding water. So what you should get among the alkenes, from the given alkenes, which you should produce a tertiary butyl alcohol. So the clue is given there, tertiary butyl alcohol. So first we need to draw fundamentally a tertiary butyl alcohol. Then you will get a clear picture which option should I choose. So a tertiary butyl, so tertiary means the carbon atom to which 3 other carbon atoms should be connected. So now this is tertiary butyl alcohol. Why? Because 4 carbon atoms are there. So butyl, tertiary. Why? Because this carbon is connected to 3 other carbon atoms. So this is fundamentally my tertiary butyl alcohol. Now you can itself tell me from the options which one you should take to get this particular product, tertiary butyl alcohol. I can easily see the resemblance in one carbon atom, maximum CH3 should be there. That is the best way I can choose the option. So from that I can understand this looks my probable answer. If you have 1 minute or 50 seconds to do the question, you don't need to do the question. From this understanding itself you can do it, because to this particular carbon already 2 CH3 are connected. So one more CH3 will come during the hydration. We will see how this happens. Okay, let's try to understand. Okay, I have tried to explain the entire mechanism. Listen. So this is the compound I have chosen. Okay, now I am going to do acidic hydration. You can see H+ is present in the medium and you are adding water. Okay, you are adding water to that. So what is happening? First, the water will undergo splittage, H+ and OH- will be formed. Now again you can analyze here. In this particular compound, which is the reaction center, I can easily say the pi bond, which has pi electron, and that is my reaction center. So this area have what cloud? I can say a negatively charged cloud is present because of the pi electrons. So who will come and approach this one? The oppositely charged species, that is the electrophile, will approach this particular compound first, like this. And again I know that this pi electron will have a tendency or attraction, or there is a Coulombic force of interaction between this, and the pi bond will undergo polarization. And this phenomenon again I can call that as what, sir? Tell me. That phenomenon again I can call that as electromeric effect. Electromeric effect. Okay, the temporary polarization of pi bond in the presence of an attacking reagent is called electromeric effect. Now many students will ask me a doubt usually, sir, whether the pi bond will polarize to here and a negative charge comes here, or the pi bond will polarize in this direction and a negative charge comes here and a positive comes here. This you need to do it and check in which case the carbocation is more stable. I can easily say when it is polarizing in this direction, the positive charge is coming on this particular carbon, and I know this is a tertiary carbon atom. We know tertiary carbocations are highly stable, and this is carbanion, and primary carbanions are more stable. So I may say the polarization will happen in this direction. Okay, so once this is happened, what will happen? The H+, once polarization is complete, the H+ will come and attack the negative charge. Opposite charged species will attract. Now what you will get? You are getting the reaction intermediate. And who is the reaction intermediate? I can easily say a 3 degree carbocation. 3 degree carbocation is my reaction intermediate. And I can say how this is stable. We know that this is alpha carbon, this is alpha carbon, and this is alpha carbon. So totally there is 9 alpha hydrogen, and due to hyperconjugation, by hyperconjugation, I can say a tertiary carbocation is highly stable. Okay. So I know this will stay in the reaction medium. Next, who will come? The nucleophile OH minus will come and attack the positive charge, and you will get our compound what is called tertiary. Why it is called tertiary? Because to this carbon atom 3 other carbon atoms are connected. Tertiary. Why it is called butyl? Totally 4 carbon atoms are there. So tertiary butyl alcohol I am getting. Clear? So this is how actual mechanism happens. I hope it is clear for you. Any doubt? Okay, so I can say my answer here is, as I told, option 3 would be my correct answer. I hope the concept is clear for you. Okay, if you find it any difficulty, please revisit the video, and any area if you are feeling doubts or why can't it be like this, you can put it as a comment in the comment box. I will be answering your question. Okay. Now we have the last question in front of you. This is one of a very good question. Let me show it to you. I am expecting this type of question this year. Okay, here you are given an alcohol, and what they are doing, they are H plus and heat. That means in the acidic medium they are heating. This is a very famous reaction. If you go to chapter alcohols, they are mentioning it very clearly, and especially sometimes they will mention the temperature also. The temperature used for this heating is 443 Kelvin. This is a famous temperature at which the dehydration reaction occurs, and this will result in the formation of an alkene. That is why you are learning this in hydrocarbons also. Okay, now we need to see how this compound will undergo dehydration to form an alkene. That is my major product, and which on further reacting with HBr in the presence of, okay, here it is absence. Actually it should be presence. Actually I need to mention it like in the presence. It's a mistake in the question, so you can think like in the presence of peroxide. Okay, you can think like in the presence of peroxide. Okay, HBr, you have HBr is present, and in the presence of peroxide, what is C, or which is the major product here, and the main product A and C, what are they? This is the question they are asking. Okay, let's try to understand the question, then you will get a clear picture. Okay, let's see the mechanism. So the first thing what you need to do here is, you have an alcohol. First thing I used to do is, which is the reaction center? I know that an organic compound can be reactive because of 4 reasons. Either it should have a charge, plus or minus charge. The next reason, it should have a pi bond in that case. Why? The pi bond can undergo polarization and create charge. Charge will make the compound reactive. The third reason is, the compound should have a lone pair. Lone pair is present means there is negative charge. Then the compound will become reactive. The fourth reason is, there should be some carbon atoms which should be electron deficient. Electron deficiency means it's a sort of positive charge. So surely there will be reaction. So in this particular compound, the alcohol, it is reactive because the OH group has, or oxygen atom has 2 lone pairs, and these 2 lone pairs make this compound reactive. And what is happening here? We know that a negative charge, because of the pi electron, a negative cloud is present. So first step, we know the medium is acidic. The H plus will come and attack the lone pairs. So what will happen? The lone pair present here will be donated to the vacant orbitals, or vacant orbitals of hydrogen. This electron pair will move. Okay, or we can say when it is coming here, this electron pair will be donated to the vacant orbitals of H plus. Now what will happen, sir? What will happen? Now I can say here water is formed and oxygen has lost his lone pair. Because of that, you can see a plus charge is appearing. We know that an electronegative atom like oxygen with a positive charge is highly unstable. So what it will try to do? It will pull the electrons that is present here towards this direction to make it stable. Because of that, I can say the bond strength would become like this. You can see here, I'm drawing it for your understanding. Bond strength will become like this. The electron density is more near to the oxygen and the bond is like a wedge shape. So this can easily undergo breakage like this. Okay, I hope it is clear for you. Now because of that, what will happen? You are going to get a carbocation. Okay, so you can see here a positive, these electrons are moving out, so a positive charge will come here on the carbon atom. Okay, you can see here a positive charge is coming on the carbon atom. So this is the first step. So please remember, in elimination reaction of alcohol, the first step is always protonation. Protonation means attacking with the H plus, and you are getting a carbocation. But please understand, this carbocation, what you have got here is 2 degree. Why it is 2 degree? Because it is connected to one carbon here and another carbon here. So if it undergoes some rearrangement, so that rearrangement is called hydride shift. What it can do, this plus will migrate to a tertiary carbon. This carbon atom is connected to 3 other carbon atom, so a tertiary carbocation is more stable. So what sort of shift it will undergo? Hydride shift. Hydride shift means hydrogen along with a pair of electrons from the nearby carbon. This is positive charge carbon, from the nearby carbon it will migrate to here. Why it is migrating from here, not from here? Because if it migrates to here, this positive charge will disappear. Why? Because these 2 electrons will move to here and the positive charge comes here. So I can say this will become a tertiary carbocation then. But if it happens from here, you will get a primary carbocation which is highly unstable. Okay, so this is how a hydride shift occurs and you are getting a tertiary carbocation. Now you can see, this is my alpha carbon, this is also my alpha carbon, this is also my alpha carbon. So totally how many alpha carbons are present, sir? 8 alpha hydrogens are present. 3 alpha carbon and 8 alpha hydrogen. So I can say through hyperconjugation, now this carbocation is highly stable. Okay, once this is formed, next step is what? What will happen here is, since it is a elimination reaction, when heat is applied, what will happen? This hydrogen will have a tendency to move out as H plus. It came out here as a hydride. Now when heating, it is moving out as an H plus. When H plus is lost from there, you will have a pair of electrons. So this pair of electrons will move to here to remove this deficiency, and this is how you are getting an alkene here. So this is the mechanism of dehydration. Okay, I hope you understood. Okay, now you can ask me a question, sir. Why should the H plus should move from here itself? Here also hydrogen is there, 3 alpha hydrogens are there, here also 3 alpha hydrogens are there. Why can't it be moved from here itself? From here hydrogen is moving out, H plus is moving out, and a double bond comes here, or from here you will get a double bond. Please understand, it will always form. We have learned the sites of elimination rule. Whenever elimination happens in such a way that the alkene formed should be highly substituted, or it should be highly stable. When we say an alkene is highly stable, when it is highly substituted. So here you can see, when double bond comes here, you can see here this carbon atom has usually a alkene looks like this, CH2 double bond CH2. Now if you compare this with this one, these 2 hydrogens are substituted with the CH3. Here also 1 hydrogen is substituted with the CH3. So I can say this is a 3 substituted alkene, or I can say it is a most substituted alkene that can be formed from this particular compound by sites of rule. That is the reason why you are getting this as the answer. Okay, so I got my product, my first product I got. So let's try to see what is the next one. Okay, so how many options resembles that? So I can easily see option 3 and option 4 both are getting the same product as like watt hours. We need to do the next step, that is HBr in the presence of peroxide, which is nothing but Anti-Markovnikov's reaction. So I am taking that particular alkene and I am going to do HBr in the presence of peroxide. So here some students have a learning, like you can easily do it. Like it is against Markovnikov's rule, or we say anti-Markovnikov's rule. Anti-Markovnikov's rule means whenever you have HBr, the negative part of the addendum, that is Br minus, will go to most hydrogenated carbon. That is anti-Markovnikov's rule. Markovnikov's rule states that the negative part of the addendum will go to least hydrogenated carbon between the double bond. So here if you see this double bond, across the double bond only this HBr will get added. So if it is Markovnikov's rule, the negative part of the addendum will go to least hydrogenated carbon. If it is anti-Markovnikov's rule, the negative part of the addendum will go to most hydrogenated carbon. That is this one out of these two. Okay. Now directly you can do like that, and you can put Br here and hydrogen here. So this is my final product. Okay, this is my final product, and you can choose the answer. You can choose the answer like option 4 is resembling our answer. Okay, I hope you got a fair idea. Now some students will ask, sir, we are not interested in directly applying the rule. We need the mechanism, how this anti-Markovnikov's addition happens. Very simple, sir. In the presence of peroxide, what will happen here is, we know that if you look at the structure of peroxide, H2O2, this is a simple peroxide. So what is the peculiarity of this structure? This structure is symmetrical in nature. So what will happen when it is trying to break the bond? One electron will go here and another electron will go here. So you are getting something called free radicals. Free radicals are generated. What is the importance of free radicals? Always a free radical will force other compound or any other bond to undergo homolytic fission. Homolytic fission means one electron will go to one atom and the other electron will go to other atom. It will not be heterolytic fission in the presence of a free radical. So that is how this OH free radical will force the HBr to undergo homolytic fission, and it will produce another two free radical, that is H dot and Br dot. So what this H dot will do? H dot will combine with the OH dot and form water. Okay. And what this Br dot will do, this is like a continuous reaction, man, continuous chain reaction, something like our cancer actually. Keep on continuing. Free radicals are highly reactive in nature. So this Br dot again will approach this pi bond. So what it will try to do, I have already told, in the presence of a free radical, always even pi bond will not undergo polarization. Rather, it will undergo homolysis. That means the one electron will go to here and the other electron will go to here. So you will get two electrons like this. Okay. Then what will happen? This Br dot have an option either to go and attack here or it can go and attack here. Now please understand, if it attacks here, you are going to get an intermediate. Suppose think like Br has come here. I will show you that. Suppose Br has come here. Now you are getting an intermediate that is secondary in nature. This free radical intermediate is a secondary carbon or secondary free radical, 2-degree free radical. But if this Br is approaching this one, you are going to get a tertiary free radical. We know that on comparing the reaction intermediates, in the case of a free radical, a 3-degree free radical is more stable than a 2-degree free radical. And that is the reason why Br is approaching here and it is forming an intermediate which is 3-degree in nature. Okay, I hope you understood the logic. And the next one is H dot. H dot will come and join here, and this is how you are getting this particular product. What you have already applied anti-Markovnikov's and written. Now I have explained the mechanism for that. Okay, so please, all these mechanisms are very important. That will give you the confidence. Whenever a new question comes, you can easily apply the same concept and get the answer. So don't by heart organic chemistry, understand the mechanisms and try to do it. That will boost your confidence. I can say you need very less revision, sir. That is the importance. If you understand the mechanism and learn the chapter, you need a very less revision. Okay, so I hope today you have enjoyed today's session of organic chemistry with hydrocarbons. We will continue this continuously. So please, if you have liked our explanation, description, everything, please subscribe our channel and learn well for the NEET 2024. Thank you.